Hello, everybody.
I'm just doing a super long millennial pause. Okay, there we go.
Yeah, stare at the camera.
Yeah, we're streaming. We're good.
Okay, welcome to the twilight of programming. We program while it's still possible. Without, it's still possible to do it.
We program things that no one would ever care for.
Yeah.
In a time where we can still do the thing we like to do. Oh.
Yeah.
What a waste.
Yeah. In 5 years' time, you won't be able to do this. So
I mean, I'll keep the skills. I mean,
yeah, I mean, you can do it, but it'll be like
it'll matter even less.
Yeah, it'll be like those people who maintain steam engines, you know. They have a hobby, they maintain a steam engine. We can maintain a code base.
Yeah, that's fair, but like I don't believe that, but
right.
Yeah. Obviously I can be wrong, but
I can say it now, and then I'll look
now.
like an amazing, future predictor person.
If
I'm right, and if I'm wrong, then
well, the thing is, you won't be an amazing future predictor because half of the population are predicting that. I'm the amazing future predictor because only the other half predicts what I'm predicting.
Yeah, okay. I'm convinced by that. Okay, so we have to decide what we're going to do.
Yeah, so this looks great. So I think maybe you've made progress on the graphics 2D library.
Yes.
I think that would be kind of cool to explain.
Yeah, so there are a couple.
I know it's simple, but I think it's also kind of beautiful in its simplicity. So
okay, we can start with that.
It's nothing like entity component system, but
no, I mean we got something to talk about there as well.
Yeah,
but,
let's do that next.
Not as interesting.
Let's just start out easy.
So we can. Yeah. So what is the problem? The problem that I was trying to solve.
Oh, you were trying to solve a problem?
Yeah, yeah.
That's interesting. No, it's usually that's not how I start.
Oh, okay. Yeah, because I was getting very annoyed. Okay, the problem's not here. Let's go to what's it, the platformer one? I don't know. It'd be great if I called it I can't remember what it's called now. Camera 2D platformer.
Yeah.
Yes. So what you have to do, the way the coordinate system works in Raylib is that the origin is at the top left.
Yeah.
And this was I don't know. I always had to, especially for the
You've never used Excel?
Game. No, that's my problem. My problem. That's I was just getting to that, Walter. My problem is that I don't use Excel, and I'm solving it by writing functional programming evaluator for graphics library.
Okay, cool. That makes sense. Yes.
So, wouldn't it be great if my coordinate system started? Well, it was the origin of my coordinate system was in the center of the window that I make, and so it's somewhat independent of the. If I change the size of the window, then things are going to work.
Yeah,
and also the y-axis y values increase when you go up and decrease when you go down. So by default, it's the other way. It's the other way. Raylib. So yeah, so that was what I wanted to do. Then thought, well, why not make a graphics? That was the motivation, and then
I like that.
So then I thought, well, how do you do this?
Well, you create an algebraic data type.
You create You
How
create
else
an
would you do
algebraic
that?
data, and then you create an interpreter for your algebraic data
I
type.
mean, that's how you solve every problem.
Okay, so the idea of this is that you have it also has to be a monoid as well,
Yeah.
because it has to be so
Why
we're given
does
those
it
requirements.
why does it have to be a monoid?
Well, more monoids better.
Yes. More
So
monoids is less monoids.
yeah. And so
And
right, so
less is
this is not everything I want to do, but this is the least that I needed to do the orbital example.
Sorry, but
So you
I just want to
yeah.
say again, more monoids is less monoids because of append, and less is more.
Yeah, I see now.
Yeah.
Thank you for explaining the joke.
Yeah, no, sometimes, it's my thing. Okay, sorry for
Although it doesn't
interrupting.
look like a monoid, but this is the best that we can do. I don't know if the lean people don't like monoids, or they just haven't got around to putting it in the prelude yet.
Well, what's also nice
It could
about
be either.
append and inhabited is more understandable. It's more
Yeah,
approachable. So inhabited is hard, but like in a subtle way, but you kind of have to face that when you're doing dependent types.
yeah,
And append, you can, yeah, everyone knows append. So where monoid is kind of a scary word.
that's true.
So maybe it's that, but
Yeah.
I don't know.
The weird thing is that it is like inhabited is you don't think of like
Like a
an
zero.
empty monoid. Yeah,
Yeah.
it's sort of like it has a dip. I don't know.
It has a
Maybe
different
I think of inhabited as in like the uh yeah we've done too much proof engineering. Essentially, that's what's happened. I think it literally just means that there's a default value which you can use rather than it meaning
I
what we think
agree.
it means.
I
Yeah.
agree. And that's, I think, why I found some of the documentation confusing.
Yeah.
But if I read the documentation as if inhabited is zero, then I think it would make more sense. Maybe not the documentation, but some of the books.
Right. Yeah, because even here, like it's designated element, appointed type. You know, I don't
Yeah,
know.
if you
Anyway,
do
so
array.get, that's a good one.
yeah,
And you don't have the index in your array, then you get the default. That feels like a zero value.
yeah. I think it.
It's not very explicitly stated.
Yeah, I mean, it says here this doesn't have any particular specified properties, but it's often an all zeros value.
Oh, okay.
Off. Yeah, so it's actually I actually use this in the entity component system. Okay.
Okay, well,
But
let's
anyway,
stick
so
here for a while. Yeah.
the the primitives of this little language are
Mm-hmm.
you can make lines. This is probably a bad name, so but you can make a circle or a rectangle, and the way this works is the circle is when if you just render a circle. Right. So let me just say there's a render component to this as well, which is the interpreter for this DSL. So you have a render function. So if you just render a circle, it's just a circle centered at the origin. And similarly for a rectangle, it's a rectangle that's centered at the origin. And so what you can do then, you have these like other bits here of the language which you can modify existing pictures. So basically you can make these are like the primitive things that you can make, and then these are ways that you can modify Yeah, so you can say I'm going to change the color of the whole picture.
Yeah,
so I can make a picture that's
yeah. I'm kind of interested in color. Okay, but first explain.
Yeah. So the point of this is that I can construct a picture, which is, say, using pictures here, I can construct it that's a circle and a rectangle, and then I can wrap it in color, and it will color both the circle and the rectangle. So, so I'm like grouping together a picture, and then these modification functions will change the whole picture.
Yeah.
So similarly for translate and then scale.
But it's interesting. I can have a circle without a color.
You can, because there's a default color, thankfully, and so
the color is inhabited.
The color is inhabited, indeed.
Okay.
So, and this comes here, and the default color is transparent.
Oh, that is a good one. That is a good
that's a good 0. I thought it was very lucky we have that. Otherwise, you'd have to choose one.
Yeah.
When you run the interpreter, but
yeah,
we have a good 0.
Okay, so Raylib has a transparent color. That's
yes.
That's cool. Okay.
So then if we look on the right hand side, if you have a picture, then you can render it using Raylib. So the thing on the left is not doesn't depend on Raylib, and then the thing on the right is given a picture.
Sorry, I want to distract. If we can go back.
Yeah.
I do want to get to render, but I just want to double check. Raylene types. Does that depend on Raylib?
No. Hold on. Let's have a look. Yeah, I think it used to, but now it.
Okay, you clean it up.
What? Not going to. Okay. It's not. My go-to definition is not working.
Okay.
Ew. No, that's not. That's not where I want to go. Oh, that's sad because I just jumped to I know. Maybe because I jumped to definition in the. Maybe got confused. I jumped to definition in the to something in the Raylib standard library, right? No.
I bet you it just happens for Raylene.
Yeah. That's annoying. No, it's trying. It's like falling back because it can't find it. Maybe it's open. Can't deal with. Yeah. Okay. You can't do it on open.
Okay, fair enough.
That's sad. Yeah. So this one doesn't depend on Raylib anymore. Yeah. So it's just the types.
Oh, that's very cool. Okay, I love that. Nice. Okay.
So I still don't know whether to put the namespace types here.
No, that's fair. No, I don't know either.
We'll figure that out. Because we could have import Raylene types and then still have it under the Raylene namespace. Probably thinking about it, that probably makes sense.
I struggle with this. I don't know these practices. But it looks fine. I'm just happy it doesn't depend on Raylene anymore. Because it's like, I think you want your game to kind of be independent, except in your main, where you're doing the rendering, where you kind of have to depend on Raylib.
So basically the only part of when you're doing the game, the only part that should depend on Raylib is when you call render picture.
Yeah.
That's the thing that
okay.
So we just have another layer of indirection on top of Raylib here. So we've gone slightly beyond the problem of coordinate system. But the idea then it's like, well, although I'm not using this feature, but the way you can group together circles and rectangles and other things, lines and so on, and then independently scale them as a group. And then I want to add rotate as well, so you can like rotate stuff. Yeah, especially things like if we add images will be added to this and be able to rotate the image or rotate an image in combination with other things. So I think it.
What does translate do?
Right. So remember when I said that when you construct a circle, it's at the origin?
Yeah.
Translate is that you use that to put it where you want it to be. So the way you use the APIs, you create a circle, and it has the transparent color, and it's at the origin. Okay, and then you use translate to put it where you want it to be, and then you give it the color.
Nice.
So, yeah. So in the window, you can see some stuff here. So, yeah. So I'll make a rectangle, and it has color. It has color red, and then I scale it by 20 on the x-axis and 20 on the y-axis.
Nice.
Then make a circle, radius 100, has color blue, scale it by half. Then I make a line, a color black line. Then I make a picture by appending all that together. But then I translate this. So the rectangle and the circle are sort of on top of each other at the origin. So the circle is at the origin, the rectangle is centered at the origin. Then I move the combination of rectangle and circle. I translate it.
Yeah.
Along the x-axis and then below the y-axis. And then I add the line, but without the translation, and then I scale like this. So this is just to try something else. Yeah.
That's very cool.
So yeah, they start. So they started at the origin, but they've moved as a group now. So you can do stuff as it.
That's beautiful.
You can just So
not the picture, but the code.
Yeah, no, the picture's horrible. Especially the drawing of text is awful. Makes you want to vomit.
Yeah, but like it's very cool. It's also pretty readable because now all the parameters are named.
Yeah, exactly.
By accident, right?
Yeah, yeah. So
very nice.
So so if I go back to basic, so obviously there's stuff missing here. So image is one that that would be okay. That would be okay to add. Similarly, image scaling. I just didn't need the image for now. And then rotation is interesting because yeah, so you got it when you rotate something, you have to have like a center of rotation. And so if I added rotate like translate or scale, the sensible place would be the sensible center of rotation would be like the center of the combined image.
I see.
And then there's no Raylib API, I don't think, that will just do an arbitrary rotation. You'd have to but you'd have to define like what rotation means for a circle, and so if the circle's at the origin, then rotation doesn't change it. But if it's at the center of rotation is offset, then it would would rotate around the center of rotation. So I don't know whether it's possible actually with Raylib to implement that rotation stuff. I think you'd have to use the fancier APIs, because rectangle is just like the simple API. But if you want to do the rotation, you probably have to draw the lines, like figure out what the angle of the lines were and actually draw out the.
Whoa.
Yeah. So.
Oh yeah.
Yeah, because the rectangle would rotate, either rotate at its center, or it could be the center of rotation could be anywhere, because it would be the center of the combined image. And so I think rotation would be difficult to implement. But it would be really nice if you could do that.
Yeah.
And then you could add other shapes, of course.
I don't know where I would use it, but I feel like it's very important.
Yeah, so I was thinking, like, if I had, in the orbital game, You'd have like
so there's some potential for rotation.
You have rotate. You want to rotate your spacecraft around the body.
Yes. Yeah.
But also you want to rotate the body and the spacecraft around another body. So you'd have so you have like multiple rotations happening, like a moon orbiting the Earth, and then the spacecraft is orbiting the Earth and the moon simultaneously. So you have like two centers of rotation happening.
Okay.
And then and then you want to rotate the spacecraft itself as you move, as you move the, you point in a different direction because you want to fire your rocket in a particular direction. So you've got that rotation. So yeah, that's the motivation anyway. But
okay, then I think it might be worth watching that Conal Elliot talk on denotational design. Like I can't remember, but I'm pretty sure he does rotation.
So I think I'll check that out, and as well I think there's a limitation of the API here because
I guess I can watch it for a fourth time, but I do enjoy that talk.
So this draw rectangle rec, right? It doesn't have any rotation. Like it will always be aligned with the, the one side is perpendicular to the y-axis and one side, one side is parallel to the y-axis, one side is parallel to the x-axis.
Yeah.
So that's just how. But the Raylib API gives you more. Gives you more stuff. Yeah, so like you can draw rectangle lines, and of course you'd want some way of. You'd want to use the version that gives you line thickness, or filled or not filled rectangle, or all this kind of stuff. But I think what you want is you have to use this draw poly, I think, or some draw poly lines or something, because this gives you the rotation. And so you say like, well, this is my center. I've got four sides. Well, you'd have to figure out what radius means in this context.
Yeah.
And then, interesting. Okay, and then so then the scaling doesn't work with this one. So this is like a draw poly, I guess, is like a regular polygon. So all the sides are going to be the same length. Okay, so you have to then go down the list and figure out which one you want to use.
Interesting.
Yeah. Here's one. Draw rectangle pro, and it has a rotation. So you could just use this then.
I mean, okay.
Yeah. Anyway, so that's down the line. That's down the line. In the meantime, this is just the interpreter of the language. So
I guess that library design is what happens when you don't have optional arguments or algebraic data types. Then
yeah, it reminds me of
you kind of have to do that.
Yes.
And overloading. You don't have overloading.
Yeah.
Yeah.
This is what you end up with, and this EX is, I think, a convention from Windows APIs. When you have like newer versions of the APIs, they put EX at the end.
I mean,
they give you more different.
One is EX or
I don't know. It looks like we have Pro, and then we have X. And then we just give up.
Okay.
And use a new name, I think.
Okay, fair enough. Yeah, it must have been pretty hard naming here.
Yeah, so I think you Catmull ROM.
Also, I decided to capitalize R and not M. Interesting.
Yes.
Inconsistency. Must have been. I don't know what catmull is. So maybe I'm. But okay,
we're not allowed to criticize the Raylib API.
It's like
it's given to us from the gods and
for free
from Ray-san himself.
Yeah. It's the only C library we could probably get to compile with.
Yeah, exactly.
So, yeah. So yeah, no, pretty happy with it.
Yes.
Okay, but let's go to render. I wanna understand
So
what render does.
So render's just an interpreter on this language, and so so these ones are straightforward. The ones that just create the well, blank is straightforward. You do nothing.
Yeah.
Now the rest of them depend on some. The rest of these depend on some state. So that's why we have a reader T here with some context. And what our state is, what is our current color? So that one is the easiest one.
Okay.
Yeah, if we interpret a color, then we just say
Oh wait, sorry,
yeah.
can we go back to the, can we also open the on the side the
yeah
thanks. Okay, so what's interesting here now, I see. Color isn't just a color, it does also take a picture.
Exactly. So it says that
colors this picture. Okay.
Yes, it gives like, it's sort of like adding an attribute to the picture.
Yes.
Okay. And a picture can consist of other pictures nested inside it.
Yeah.
So
that's why you're not just setting the color, you're also rendering the picture with that color in
exactly
online 52.
Yes. So, well, it doesn't render the picture with the color. What it does is it renders it. So it this is kind of back to front, I guess, because it. Yeah.
Okay. We couldn't do this. We couldn't add the notation for the back arrow.
Yeah. I'm just trying to think now. Maybe this looks wrong.
Yeah.
Hold on a second. But it's clearly not wrong because it works. We're in that situation. Oh no. So because it's this arrow here, we shouldn't use this arrow. Yeah, let's not use the arrow because it's confusing. So oh no, but yeah, okay. So it's confusing because the way you have to read this, let me just get rid of the pipe. And so it looks like this. So what it's saying, so render picture gives me something in reader T. Right? And what this local says, it says evaluate this reader with this new context given by this. So so what local does, it sets the context and then runs the nested reader with that new context. And so maybe we should, because I'm using this dot syntax, which I don't think is appropriate here. So
how about,
because I was confused. So basically, it should say reader t.local, and yeah, I think this is probably better. So you say reader t.local, and then you give the reader, then you give the function to modify the environment, and then the thing that's being modified, the thing that's being run after modification.
Okay.
So I think this would just make it clearer. So I want to say, in this case, you don't want to use that dot thing because it's
okay.
So
let's
see whether this makes it any clearer, because I also got confused then.
Yeah, I think this helps. Yeah.
So
yeah,
and then we can add the.
Oh, that works.
Yeah. So what this is saying
That's reasonable.
Yeah. So this is the thing to modify the environment. So I'm just setting color. Then this is using lenses. So I'm setting the color to be C in the environment. And then this is the thing that I'm then rendering underneath that modification.
Yeah. No, that makes sense.
Yeah. So that's what this should look like.
So we can probably fix the next one as well.
Yeah. So the next one, has this function in it. So, well, let's just write it like this, and
yeah.
Then maybe we can use the pipes to reorder it. So I want to do that. No, I just want to do render t.
Reader t.
Oh, reader t, yeah.
They're kind of the same.
Yeah, then I have to give the function.
Yes.
And then render picture.
Yeah.
Okay. Yeah, this is better.
Yeah.
Same here. So first I do the reader t local. Yeah.
Cool.
Okay, so that's clearer now, right? So it means I'm doing this first and then I'm doing this. But if you use the dot syntax, it looks like I'm doing this first and then changing the thing.
Yeah. Very
okay. Yeah.
Yeah, but no, this reads fine. I mean, reader t local is still bad.
Yeah, so I added this. So this is like fine. A Haskellism.
Oh, okay. Yeah. Okay.
So this is something that's not in the standard library, but what it means is that because what I don't want to do is I don't want to use a state, right? Because it's not a state. I'm only affecting
downstream.
I'm only expecting the reader downstream. So you want to use this.
Yeah, I'm happy with reader
state,
t.
Yeah.
Okay. It's just right.
So the color, what it does is it sets the color to the new color and sets that in the environment, and then renders the picture with that new context.
I would almost just say reader t dot set.
No, because it's not setting.
It's not set. No.
No, you give a function to modify the environment. Yeah. I mean, you could have one that just, but it would be the set would be a lens. So you could, instead of writing row to row, you could write lens blah blah blah. And you have a lens API.
No.
But but sometimes, like for the next example, you're not just setting. You have to fetch and then set. So
yeah.
Yeah.
Yeah, no, I screwed up. Okay.
All right, so let's look at scale because that's also easy, and then I'll explain translate.
Cool.
Oh, yeah. So scale, I have a scale vector, which is just like the x and y scaling factor for all of the points.
Cool.
And yeah, so over is this lens thing that says, it digs into the scale here.
Yeah.
The scale field, and then it then applies this function to it and then wraps it back in the context again. So this just says that
apply
applied this to the scale field. Yeah.
And that's it.
And leave everything else the same. Yeah.
Yes.
So this dot is just the vector dot product. So it multiplies the current scale by the scale factor. So, and the initial scale is 1, 1.
Aha. Okay. Cool. All right.
So that one's okay. And then the pictures, if you have multiple pictures, then I just map them over all of them.
That makes sense.
And then I'd have to do this because I want it to be in unit.
Okay. Yeah.
And actually, why? Oh, because there's no map m underscore. Yeah, because I don't care about the result of these. Yeah.
Makes sense.
So this one is the interesting one.
Yeah.
And to explain this, I will open the PR because I only added this yesterday because I'm still not 100% sure about how it should work, but this one is the so Right, so we have two cases here. So the question is that translate and scale, and then I claim that they're not commutative. So, and here's my argument. So if I create a circle,
yeah,
then I translate it by t, and then I scale it by s. So what does that mean? Well, I have a circle, it's created at the origin. I translate it by t, and then I scale that whole picture. And so that the circle will now be centered at t dot s. So, because I've scaled the translation by the scale factor. Now, if I translate a scaled picture, well, I start with my circle at the origin, then I scale it by s, so I've just made this circle bigger, then I translate it by t. Now my circle is centered at t and not t dot s. Yeah.
What it
So to ignore the radius of the circle, just think about where the center of the circle is. So in the first case,
yeah,
it starts at the origin, because that's what I said when I create a circle with the circle constructor, it renders a circle at the origin. Then I translate that circle by vector t. And so that will translate the circle from the origin to vector t.
Okay.
In the coordinate t.
Yeah.
And then if I scale that picture, then the translation, like the point t will be scaled to t dot s, the dot product.
Why?
Well, because now, this is a very good question. Why? So originally I wasn't doing this, but then what do you expect to happen? So if I have so if we go back to this picture, because what I didn't do it like this and I got very surprised. So so say, oh, this is going to drive me insane, right? We need to get rid of that text.
Nice, done.
Right. So if I have a so if I have if I translate, I thought that was a problem with my screen, but it's actually a line, I think. Yeah, good. There was a crack on my screen. It's actually there's a line here with 1 pixel width.
Yeah, I have the same crack on my screen. I was about to just go like this as you were saying that.
Yeah, I just wiped the screen.
What's wrong? Yeah.
Okay, so hopefully
that's a good default color, yes.
Yeah. So so if I translate oh god, maybe we're just trying some examples of the what I want to preserve is like the relative positions of two objects. And what I claim is that if you don't scale the translation, then when you scale the objects, they won't be in the same relative position after you've done the scaling, and that's the desirable property you want. So if I scale something and then translate it and then scale the whole thing and
I don't know. I'm not
okay, so maybe I can show what motivated this one. So I was doing orbital. And so orbital.
I just feel like your orbital math is off. not your.
Yeah. Right. So what I wanted to do. So here was the motivation. Here's how I found this issue that it's not commutative. Yeah. Right. So I have all my. Yes. So here, okay. So I don't need the pictures constructor there. I don't think that's. Oh, because it doesn't know it's a picture. Okay. Anyway, let me just leave that because that part's not relevant. Okay. So what I'm doing here is. I don't want to. I want to do when I'm drawing stuff on the screen using these coordinates. I want to use like 3 and 1 and 4. I don't want to 300, 100, 400. I just want to scale when I'm doing it. I just want everything to be sort of small numbers, and I want to scale everything up at the end. Right. And
yeah.
So, okay, so you just take that as an assumption. Paul, for some crazy reason, wants to do that.
Yeah, okay.
So basically, okay. I could just write 300 here, but I just want the numbers to be small. And then and also the maths calculation, I can put I don't have to remember to multiply by 100 here and so on. So it's just like everything is normalized to 1. Yeah, and so that's, I don't have to write 100 here. I can just write 1. For example. And so that's like a desirable thing to have. But then when I put it on screen, I want to scale everything up by 100 to make it fit inside of the window. So
yes.
Now, okay, that's a yes.
No, I'm gonna take.
So no, but I think it's so without the okay. So let me show you without.
I can understand you want to scale the planets.
I want to scale up the relative distances. So let's say I've not scaled it. This is
like you want to scale up the whole picture.
Yes.
Yeah. You want to scale up the distances between planets.
So you see here. There's my picture. So it's all happening in there, right? And what I want to do, and the relative distances between everything is correct.
Yeah.
Now I just want to scale that whole thing by a factor of 100.
Yeah.
And I want all the relative distances to be the same. Like I don't want stuff. I just want it to be as if I zoomed into that. That's what I want scale to mean.
Yeah. Okay.
And for that to be true, I need to do this.
Now you got a yes.
Okay. So that's my motivation. And in order for that to work, in order for me just to be able to write scale here, all the translations in here have to be scaled. However, if I do a scale inside of here, so I don't think I'm doing one, or translation. It's like if I do like at some point in here, I might do a scale.
Well, you have to.
Yeah, I do translate, but maybe not a scale. Yeah, but inside? Interesting. Well, this is somewhat inconsistent. Okay, so we spotted inconsistency here. So this shouldn't have a radius, basically. It should be. What? You should have radius 1, right, and then be scaled. Yeah. Similarly, this should just have a ratio, and then you scale it. And in any case,
Nice.
So in any case, if I do a scale in here, that's kind of inside a translate, then I don't want that to apply to, like, I don't want to be able to commute the scale and the translate and have it apply to stuff outside.
Okay, show me the picture.
Yeah. Yeah.
Right? And then swap them and show me the picture.
Yes.
Maybe that helps.
So in the window example.
Well, or orbital, whichever.
Orbital, yeah. Well, I can show you what orbital looks like. Maybe if I yeah, so say for example I don't do this. I just make it commute. I can't do that easily.
No.
Okay.
But they currently don't commute, right? So we can we can just swap. Oh, we can't. Yeah.
No.
Yeah, we can make those two circles, right?
Yeah.
Can we make them both radius 1 and then scale them to their actual radius? And then translate, and then later, and then run, and then
yes. So what this is equivalent. This is equivalent to scaling.
We want to do a no op.
Yeah. So scale. Yeah. So So yeah. So that's the other thing is like when you scale a circle, when you want it to become an ellipse when you do like if the left and the right are not the same. Currently, it doesn't do that, but you'd want it to like the circle. If you scale it more by the x and by the y, then it should become an ellipse, but it doesn't. Okay. So
yeah. Also, my gut is saying scales should be one number, but
well,
I don't think
you can scale a rectangle. Right. You can scale a rectangle by, and so a circle should become an ellipse. Yeah.
Yeah. No, I think.
But yeah, right. I have the same for a circle. It only makes sense to have one number here. Yeah. But it's interesting that we can actually this radius is redundant.
Yeah.
And actually, you only need one. Like the rectangle is determined by a single float rather than two floats. So.
Okay, I'm gonna actually bring it back. I think scales should just be one number.
Okay.
Because you could have
you're right.
with the ratio as well.
Yeah. Exactly. So yeah, it should only be one number.
Just an ellipse with one ratio or something.
Yeah. You're right. So scale is actually one number. That's brilliant.
I did something today.
No.
I mean, it's another no-op, but like, yeah, that's my job. No-ops.
Well, it actually solves the problem of the circle, because then we can have a separate ellipse constructor and we don't need to worry about it. Okay, so that looks the same. Then if I scale after the translate.
It's the Conal problem.
Yeah.
Okay.
So why it looks like this because so why does it look like this? Yeah, because I've translated by the smaller amount here and then scaled it. So so here I've done a translation by the
your translate is also scaled. Okay.
Yes. So that's the point, is the translation, it should be scaled. But only with the like it shouldn't be scaled it shouldn't be scaled by anything inside it. It should only be scaled by stuff that's outside it. So therefore it's non-commutative.
Okay.
Yeah, so that's the point.
Yeah, I think that makes sense.
Yeah, so that's the motivation, because when I was doing this, I just wanted to like scale it in one place. And that meant that the it meant that the translation had to be affected by the scale.
Yeah.
And if you want the translation to be affected by the scale, then translation and scale have to not commute. Otherwise, you get weird stuff.
Yeah.
So it's like it was like a discovery of. I would constrain myself into a place where the two operations had to be non-commutative. Now, before, where translate was not affected by scale, then they commuted, because that's how I had it before. But I wanted to be able to scale a whole picture. Yeah. And I discovered the fact that this property exists. So no doubt that I learned this in university, and I've just forgotten when I did vector calculus.
I mean, I definitely forgot.
But what's wonderful about this
that subject.
What's wonderful is that we learned that the API can be simpler. So
yeah.
So circle. So yeah. What should I do to do? Circle.
Is radius is ellipse?
Yeah, it doesn't depend on radius. It doesn't depend.
No. Circle is replace circle with ellipse.
Yeah.
And ratio.
How do you spell ellipse?
No hard questions.
Yeah.
no tough questions, please.
Yes.
Sorry, that was political.
To do.
Yeah, the same. Yeah.
It's a rectangle.
Just needs a ratio.
Yeah. I don't know what to say. Takes a ratio. I'll know what I mean by that. Yeah. So then everything can be done by scale.
Yeah.
Interesting.
Scale is just one parameter. I think that's the other.
Oh yeah. Then yeah. Scale also affects. Scale also affects lines. Oh, maybe this is not true for.
Well,
because they're not. Line is not. So here, it's not really a line; it's a path. So it's a path that consists. So this should be. Yeah, I mean, this should be renamed now. Rename to path argument.
Yeah, because line is an origin.
Yeah, but this is more like it's some kind of. It's a path that's composed of several lines. So it's yeah. So this path argument is like a set of. It's an array of points, and the path consists of a. Whatever you call it, linear spline or something.
I think there's still just one scale.
There's just one scale.
I don't know how to do that, but I still if you imagine a spiral, right?
Yeah.
Kind of just want the thing to. If you have one number, you just blow it up. So like whatever you did, Wayne, scale with both vectors where when x and y for the scale was the same.
Yeah.
You can just do that.
Yeah, I think so.
Can you show render for path? That's actually pretty interesting.
Yeah.
See. Either way.
Yeah. So basically what you need to do, you're given the points.
And
it's the same, it goes for all of the others. They all rely on this two-screen thing, which uses the state, uses the context. And there are two things that are happening. One is that you so this is the point that you want to draw. And you take the dot product with 1 minus 1 to reflect on the y-axis, because we already said we want the y-axis to point in the opposite way. So that's what this is happening.
I mean, you're like, I never said I wanted that, but
no.
No, I think it's cool. I think it's
No,
cool. I'm just kidding. Like, yeah, no, that makes sense. Yeah.
So that's what those two lines do, and
Yeah.
you've got two vectors going on. You've got the vector you want to draw, and you've got the vector that you want of translation.
Mm.
And and then what you do is you take the vector you want to draw, you scale it by the current scale, so you get passed in what the current state is, and then you add to that the translation, and then you add this. Now you've got the vector
Wow.
at the origin, so you add the center to get it based at the origin, because the center here is the center. So because what you're doing, you're converting to Rayleigh coordinates, right? So this part here is as if the origin was the center of the picture, at the center of the window, sorry. And so you have to add that vector to the real center, and the real center is the width of the window divided by 2 and the height of the window divided by 2. So you have the thing, and that makes all the vectors that were based on the center of the window now based on the top right hand corner.
Oh,
top left hand corner. That top left hand corner. Sorry. Yes.
So that's fine.
Yeah.
Like you have a dot product there. For scale, I think we just need a product.
Yeah. And just thinking that. So for the line, I just can't. I'm not convinced yet that you want the line. You don't want to scale both X and Y independently. I suppose you can just change the line. So say can we draw on the screen?
Yeah.
We should have with all of the features. We've got the annotate feature, right? So
yeah,
I can draw a line, and it's got some. Yeah, so it's got some angle, right? Like, but this line is really a path of many lines.
Yes.
And so I can imagine I just want to like stretch it out in the X, just in the X direction. But I wouldn't be able to do that if the scale was just a single number, because if I just scale everything by multiplying, I'm effectively like dot product with the same on the left and the right, and it would scale this way as well as this way. But I don't know whether I need this or not. I'm just saying that's what we currently have, because you can reproduce that by just changing the, I can just make this line longer and so on. But I don't know if whether we need to scale stuff like this independently. And there's also the case of, you can scale a rectangle, or you could, a rectangle is just characterized by its ratio between its height and width. But what if I have a picture which is composed of a circle and a rectangle? Like, so this is my picture, and I just want to scale it, like stretch it, but not change its height. I just want to change its width. Oh, yeah, this will also work, right? No.
Oh, that's interesting.
I don't know whether I want to do this or not. Is my question. Like, if I can only scale both X and Y, then I can't just do that. I would have to. I'd have to separately. I could mimic it by changing this ratio, decreasing this ratio on this rectangle, and then making this an ellipse.
It wouldn't be as easy as current system. So if you want to make a game where you're stretching things, like it's, I mean, it happens when you want to, like, say someone's kind of dizzy, then you kind of stretch things like this. You do this repeatedly.
Yeah. Well, maybe they're just different types of scaling. So maybe this is because you have like what do they call it? Aspect ratio invariant scaling, and which is the one you usually want. And then you have like free scaling, maybe where you give it a vector. But I think this is the one where the scaling is just a number is the normal one, isn't it?
Yeah. Yeah, but this is very interesting. Okay, it's kind of hard. I don't know.
Yeah. But I like the idea. At the moment, how do I get rid of this now? I thought it disappeared after some time.
I think you just do clear all.
Clear. There we go. There we go.
Cool.
Brilliant.
I'll miss you. Wings.
Okay, so this can be a float. Brilliant. I like this because this is. We can be a float. Circle can be
simplify mode for the last couple of months. So
yeah. Yes.
Sometimes I'm a bit too brutal about it.
What are the rest of them? Translate. We can't change.
Yeah, I'm trying to think about it, but yeah, we'll come back to that one later in a few weeks.
Well, I mean, you could translate. You could give a single number, which is just the ratio between the x and y arguments, and then you have to scale it. So it's like the length one normalization of your translation, which you then scale. So it could be. So it could also be one number, but I would think about murdering the person who made that API.
Okay, yeah. So maybe not. Maybe not.
Yeah. I might murder the person who makes me divide these two numbers instead of just writing them.
Yeah, I think it's
But then we can have convenience like smart constructors for these.
Yeah, definitely.
Okay.
Okay, let's take a 5-minute break.
Yeah, let's take a 5-minute break.
And then we'll be back soon.
Yeah.
Just streaming myself silently eating some chocolate. Cool.
Right. Let's see.
Okay, but now maybe let's look at the entity component system again.
Yes, I think that covers the rendering, I think.
Yeah.
Yeah, so this part here is this what makes it non-commutative. You do the you use the current scale to compute the current translation.
That makes sense.
Okay.
Now it makes sense.
Yeah. It's local seems like a bad name because it thinks it's a
yeah, I think it's
a keyword.
Abbreviation. Like get context.
What? Okay, context. Update context. I don't know.
Yeah, set context.
Yeah. Okay. So the ECS stuff I did. Yeah. So there were a couple of things. So we'll go back to orbital. Is this the broken one or the not broken one now? Let's see. This is the okay. Yeah, so the oh yeah, what was going to talk about this orbital types, yeah. So now you can do and I'm going to fail to explain this because I did it like 3 weeks ago. But now you have three different types of components.
Okay.
So you have normal components. The normal components can be like assigned to any entity. Those are the types of components we've seen before.
Okay.
So an entity can have a position, it can have a velocity, and so on. But then we have two other types of components. One of them is called global, and one of them is called unique. And I can't remember exactly the definition. But unique means that there's only ever one of them in your system. And so I think this is yes. Yeah, there's only ever one. So you can never make more than one. If you make another one, you just overwrite the existing one. So it is for things like player.
In the unique store.
Yes, exactly. Yeah, we can just look at the definition.
You also don't need it, right?
No, it's just a convenience thing.
Convenience.
So you can say like if you're querying it, you can just say, well, there's only one. I just know there's only one of these, so I can never accidentally create more than one.
Nice.
Yeah, this is not good. But I didn't know what to do here.
So you panicked?
What?
I didn't know what to do, so I panicked.
Yeah, I didn't know what to do, so I panicked. So yeah, the unique storage. Yeah, so you just have like an IORF to. You may have one, an entity, and that thing. So yeah. So if you get it, you just get the entity. Sorry, you just get the component. And if you check it exists with the particular entity, then it only exists for that entity if the entities match. But you should. Yeah, the get is weird. In the design, the get is weird because get kind of assumes that you've called exists.
Yes.
So it's yeah.
I don't like that.
This is a bit, yeah, I don't like it either. So maybe it'd be nice to do something with that. It just makes it more convenient to use get. That's the only thing, because it doesn't, you don't have an option here.
Yeah,
and I guess, yeah.
Why not?
Yeah. That's a good point.
I mean, yeah, it just feels like it should just be an option.
I bet it's for some performance reason that it's not been benchmarked, or that we don't care about, as in, like, we don't care about it. So maybe we can just collapse those together. Because it might be cheaper to ask whether it exists rather than. Yeah, because they're like cache stores as well. So maybe no, it shouldn't make any difference. I can't think of why it would make a difference.
No.
So anyway, so there's that one, and then there's global storage. So the other one you can have is global storage, and that is global storage. This is where the inhabited comes in. So when you make the global storage, you just get a global block. You get a global thing that's created when you create the store.
Yeah.
And then it's conceptually it's attached to every entity. So there's only one of them, but instead of being, so the unique store, there's only one entity which has that component. But in the global store, there's one component that's attached to every entity. So it's and it's precisely for storing global stuff. So I can just when I do my query, I can just say, give me the global store, and it will always get the same one. And I can just put it onto any query I want, and it will always get that one. And so, yeah, so in it, so this inhabited constraint means that when you make one, you just get the default. And so, yeah, you have to make sure that that is implemented.
Don't we also need? Yeah, no, ignore. That won't work for the unique store. So,
yeah, so this one is simply, it always exists.
Yeah.
Oh, I see what you mean, whether we could use inhabited for this.
Yeah, no.
Yeah, don't.
No, I don't think it makes logical sense.
Yeah. Yeah, because they're.
Well,
yeah, it could make sense.
If you make global components, you make world and components returns a store that has the dependent type that the unique
could
store
have it. We could,
yeah,
we could do that.
I mean, or you could just fold get exists into get and just.
Yeah, I think we should do that anyway. Yeah, I think we should do that anyway. And exists can just be a check. So anyway, so the global thing is, yeah, you always get the same one, great, and it always exists, perfect. And when you set it, you just set the one. You don't check. You don't have to use the entity argument. You just set the one that's global. So I think the global one, I think, is nice, unique, and okay. So you can also emulate this one. Yeah, because you can just create a global entity. You can create a normal store, and you just, yeah. In fact, we even have like the thing that I should get rid of, which is I was doing something to emulate this. Where is it now? Yeah, there's even this thing. So basically, you could create a component, and then just store set stuff in the global entity. And then you just start, and this is just magic, and then every other, yeah, your entity counter just starts from one. So now you don't have to do that hack.
Nice.
So this was like a reserved entity for the global case.
I mean,
but now we don't need to do that.
You're still using it for now.
Yeah, I'm still using it for now because I use it in the 2D platformer.
So
I could replace that. Where is it?
Yeah, this might be a nice demo to show.
Yeah.
Let's replace it now.
Yeah, I can't even see it because I probably split it. Why did I do that? Oh, something uses. Where does the camera go? I think this has a camera. Oh, this doesn't use any. Oh, this doesn't use the entity component system at all.
Okay.
Yeah. That's why I can't find no, bouncing balls uses a global state, I think.
But this is why we should always do something incredibly hard after work. After working all day. Yeah. This is why.
Yeah, so this has a config. Right, so I put my config here and then I can just derive inhabited. So this is one of the few things that Lean has actually you're able to derive. So you can only derive inhabited and the Boolean equality, and there are a couple of other things that you can derive. But this is one of them.
Nice.
So, and then I can just say, oh, well, what the hell? Why am I doing that then? Yeah, it was a waste of time, was it? Assuming you've got my global. And then just, okay, so this is a mixture of both styles.
Oh my God. Okay,
so I'm doing let's get rid of this one. So this is how I did it before, was like, well, I've got this magic entity.
Yeah.
Oh, how does this work?
Don't worry.
How does it know what component?
I'll ask the expert.
Yeah. How does it know what oh, it knows what component from the type. Now I'm confused because this is a config. Oh, because I can just say this. No. Oh no, because this is the explicit set. Because I don't want to set it on entity. So how do we do this? Okay. Right. So we get this is already set, and then when we do init, we want to set. We want to set the config. Interesting. How do we do that then? Because what I want to write is
okay. Well, how do we access the global store?
So we can access it, but so we can write a function. Yeah, so we can write a function like init config, and it should be config, and it returns a config, and then we can use CMap.
Yes.
But we actually don't need this argument. But that was going on my head, was like, well, how do I just do the set without the get? Because we don't actually
just ignore the argument.
Okay, fine. Yeah. So this, can I just do that then and just put it here?
Yeah.
Oh, but I need this. We'll figure out how to do that. And then I do set. Then I just do, I guess, does that?
Yeah.
Yeah. And then I do in here, instead of doing that set, I do CMap or map underscore.
Yeah.
Yeah, in its config. Could be that.
Okay, try the M, try the underscore.
Yeah, I'm just trying to see whether.
Oh, you think
no, it should be this one. So what did it fail to synthesize? Oh. Interesting. So we can't do it like this.
But it does see that it needs to look in the global storage.
It does see that, but the global the
Let's just go look at make world and components. Let's just make sure it's the right argument. I don't know.
Yeah, that's a good point.
The second one.
The thing is, though, but it does work. Oh no, it doesn't work. Okay, so yeah, I've not proved that it actually works because I'm using the old thing here. Okay, so this is great. So we'll actually see.
Yes,
I'm not convinced that the config is being used. Oh, hold on, update shape. That's getting the config passed in. So somehow have update shape. So where is that? You want to check the make world and components. Yeah, global idents.
Okay, there are.
And then it makes. Yeah, this is a horrible mess, but
no, it's not too
the global names. So yeah, we make a global component with the global names.
And then we make world global
component.
names.
Yeah, so the global component, let's see. Yeah. Make global component, global storage. Yeah. So this looks like global storage. Yeah, global storage. Global names, global storage.
There's one more global storage.
Yeah, here for.
No, in 1, 2, 3. Oh, also the entity.
Oh yeah, this is for the.
Okay.
Yeah, this is for the entity counter is actually global storage.
Fair enough.
Yeah. Well, that one you have to think about, but it's like, yeah, every entity has the entity store, the entity counter associated with it. Yeah, storage, global storage. Yeah, this took forever to figure out because what you need to do here is that you have like this is a bind, like, and you need to use this parser to parse the bind.
Oh my god.
So yeah. Okay, so yeah, so we're just making that all of these ones, and then we make the store one.
Yeah.
Okay, so I think that is right. It's just interesting. So I'd like to know why this one works, the update shape. So the update shape gets called, assuming the update shape. Yes, so I'm using a CMap here. And I give it, config. Oh, it's not using the config.
Yeah.
It gets passed in.
Yeah.
So how are we meant to use this then? Have I just not implemented members? Oh, I guess that's it. I need to implement members, otherwise it can't work. Okay. No, does that make? Because what CMap does, it has to get all the members of the store, and then it gets them all, and then it applies the thing.
Yeah.
Unless you're just not meant to use it like this. Maybe I've got confused because I think it's the unique one. Is it the unique one doesn't have a? Does the unique not have members? No, it does. No, it doesn't make sense for the global one to have members.
Why not?
Because you'd have to list. You get n copies of it because it's a member of it. Because the thing is that members returns a list of entities.
Yeah.
And so you'd have to list all entities.
Mm-hmm.
We don't. The thing is, we don't have. We don't keep track of. Yeah, we don't. global storage doesn't keep track of entities because it's kind of associated to all of them. So, but how are we meant to use this thing then?
I guess you
What can we can get it
one member.
Maybe maybe you have to use that get global, but it doesn't matter which. The point is that yes, you say get global and set global, but it actually doesn't matter what number you pass. You can pass anything. So it could, yeah. We just I've got the paper here.
You want to use explicit set for.
I think you've got to use explicit set. Not explicit set, but the set function in system, which uses explicit set.
Yeah.
So I think you have to use this, but it doesn't actually matter what entity you pass. So maybe we just need a new function like set global.
Yeah, that seems fair.
Yeah, and it doesn't use, but it has to use a number. That's the thing. But it doesn't matter. It would just be like. Yes, it would just be, well, it's just going to be all of this nonsense, but without the entity. Yeah. Yeah, but it would also be only for global. Does that make sense? Yeah, let's just look at how you want to call this thing. So I think I was doing it right in inverted commas, but it doesn't look right.
Okay.
What was it? Oh well, let's put it back here. So as it currently stands, what you meant to do is let me just go here. What you meant to do is set. You have to use set prime still, and then global, and then well,
just remove the parameter.
Yeah, remove the param, and then you meant to say init config, but it just doesn't look right. Yeah, and then when you want it, you've got to get it global.
Yeah.
Okay.
So technically, you could hide global in the library.
Yeah, so you would have. Let's try that. You'd have a get global and set global.
Yeah.
And then let's just try and write that. So it would, and we wouldn't need this family def business for it, because we could just we'd use set prime, but
yeah,
we just
set prime.
Yeah, set global. But here I can just put
I'm saying we can just define global here, just like we do in the other file.
Right. So you just want to define a number called global, or
yes.
Yeah. So global is like entity 0.
Yeah. And then just set global just calls set prime with global.
Yes, but I also want to change the constraint, because I don't want, you should only ever use the set global with a global storage.
Yeah.
Yeah, but that part of it is right. Set global X. So that's already working as we want it to.
Yeah, and now we can remove stuff.
Yeah, now I think, I'm just trying to think. So we don't want to remove it. So it's this S would disappear. Yeah, we want to remove S, and then this would be global still. How do you even do that? Global storage C. Close. Whoops.
I think now it's a circular import, right? So
yeah.
Maybe we move state global to below the global, or in the global storage namespace or something.
The global storage namespace.
Like, yeah, the right, not 74, like 75.
So we put set global here.
Yeah.
But we wouldn't be able to use. Oh, does this import? No, this imports store. I think this can import store. Yeah. Oh, maybe it can't. I see what you're saying. This because this
I think I was wrong.
Yeah. This could import system maybe, but it's odd that it would. Maybe they're just like.
We could put it in a separate
this can import.
file.
You could put it in a separate file, but I think it's okay to do for now. Let's just import store. Let's see if that works.
Yeah.
Yeah, okay, great. And then this thing, hopefully that will work. And then hopefully this will work. Yeah. No, look.
Global?
Yeah, I mean, we'll have to put it there, but it's a shame we can't figure that out. Well, maybe. Yeah, no, it couldn't really figure that out either. Okay, fine. Oh, I don't even know where that was now. Yeah, here.
So that also has to be global storage C, right?
Yeah, let's just. Maybe that was the issue then. Was. I think some of this isn't necessary, but
that's okay.
Yay! Okay, brilliant. Now we can do. So this shouldn't.
Now we can do.
This is going to exist in that other place, and we can start from 0. We don't have to start from 1.
Yeah.
So I can just derive. Well, let's use the set global first. Make sure it works here.
Yeah.
Oh, that should be okay. And then it's going to complain because la la la. Let's see. Oh, yeah. Global's already been declared.
Okay.
Well, let's just change this. Let's just change this global for now.
We can call it global 1.
Given up. Yeah, I'm going to call it global 1 as soon as Emacs is finished doing what it's doing.
Oh, okay. So it's got more important things to do.
It's got more important things to do.
Yeah, editing.
It's completely dead.
I didn't know.
Yeah, well, this is Emacs for you. Oh, I've also got other side Haskell LSP running, so probably what's going on there. Okay.
Okay, maybe, yeah, thank you.
And then where were we? We were system. Yeah, we can call it. Oh, and also we forgot to, yeah, we don't put an entity here. But when
just
no, we can inline this maybe because no one should ever use this global one.
We're gonna use it for set as well.
Oh, you're right. Yeah, we are. I can't do that. Oh, yeah, I can do that. Just don't give it a name. Yeah. Interesting.
There we go.
Okay, now we go back to bouncing balls. So that should work now. Okay, LSP mode. Yes. Okay, I'm setting global. So I can do just run goal. Oh yeah, no, it's fine. I thought it wasn't working, but I need to actually.
Oh, I was also like, what?
I need to actually. And there's a button I can press to remove them, but I can't remember which button it is now. Anyway,
Cool.
Which button is it? Remove, delete. Key down R. Okay, of course. I think R is the only. Yeah, we don't have all the keys present, so you have to pick keys that we've mapped. So R was the. Okay, great. That seems to work, and then
cool.
We can also do get global, right?
Yeah. Oh, we just did get global. Oh yeah. Oh no, we did set. Sorry,
Yeah.
We want to do get. Yeah.
Yeah. So similar. Do we need? Yeah, I wonder if we need these.
Is it C is unused? Is it?
Yeah, C is unused. That's the C refers to the thing in the text thing in window that we.
Oh.
Yeah, this one. We can put it back. Oh, yeah, it's unused because it was meant to be used. Okay.
Oh.
Yeah, that's
okay. No, we don't have to put it back. No, it's okay.
you said, you insisted. Walter insisted.
Oh, just ignore the lint errors, Walter. Just ignore them. They're never right.
Let me just see if we can. I don't know.
Yeah, no.
I'm just intrigued because this is saying like I'm constraining global storage to have X plus set, but no, okay,
No,
it's
that
not
one
guaranteed. Okay,
that you need.
Yeah, this one you also need because it's saying like the world has this in it. Yeah, okay. Well, we can't get rid of those.
Just
okay, so
more classes for everyone. Everyone's learning something.
Just trying to make the pipe signature slightly less scary. And this one, it just looks ridiculous because it just has all of these global storage everywhere.
They're
all concrete.
It fits right into place. I would. It would be weird if it didn't look like this.
Yeah. Yeah, this one also because it's saying like I'm constraining that the element of this should be T, but the element is C. The element is C because the instance of LM family for global storage is just C. So like I'm sure there's something can be. There's a lot of redundant garbage in here.
Probably remove T.
I think T can go.
And then just make everything C.
Why is that complaining?
Because it adds an implicit.
Oh yeah, I didn't even need to put this in.
No, it's good. It's good.
No. What I mean is it wasn't necessary, but
I know, but it is there. But remove T.
I think T can go.
And then remove it everywhere and replace it with C.
Well, we can. Oh no, it probably have to be C then. Yeah. Okay, we remove one thing.
See, that's good. Yeah.
It looks worse now because it's just C's everywhere.
Well, I like
it looks. No, but at least the other thing had the illusion that these classes actually meant something. Now it's just saying.
Well, I like to be explicit with my implicit arguments. So
yes, but the thing is, like this. Well, sure, I'll just delete this one. Okay, it's still type checks. What about this one? No. Yeah, because that one's saying that that one actually is actually saying that C has. This is the important one because this says that the storage for C is global storage.
Okay.
And this one says that. Well, this one actually says that. So yeah. What?
So you're just saying it twice?
No, but this says something else. So maybe actually this can be underscored. No. Yes,
it's okay.
Yeah, okay. No, well, hold on a second. But look, it says like, I am the storage. I'm the storage family for C. The storage family for C is S, and then the element family for S is T.
No, it's saying it requires that.
Yeah, saying it requires that.
Yeah.
But we've already said that that's the case. Oh, S. Oh, I don't know. I thought. Okay, well, we got rid of one thing.
Yes. Now
Okay,
let's do
good.
get global.
Okay, global. There's no T here. Oh, there is a T, but I didn't put them. I didn't put the types.
Yeah.
Okay,
See?
never mind.
See how useful that would have been?
It would have been very useful.
Yeah.
Oh, I don't want to do that yet. Okay. Fine. Now we do our thing. So we don't need an entity anymore. And we just
first
call
write
get.
it out. First do get global, and then
Yeah. Oh right, yeah.
And get global 1 before you start removing.
Oh, we don't need to get global 1, do we?
Yeah. Get space global 1 on line 27.
Oh yeah, sorry. I see what you mean.
Okay, now we can remove stuff.
All right. So then we actually want to, the whole.
Yeah.
This should be global storage.
C.
Element fam.
S. You need to replace S with global storage C. If we still need it.
Yeah, I'm not sure. The global storage needed what? Needed this to be true. Oh, it needs get and set. Okay, so get. It only needs get for this.
Yeah.
So what do we remove the other one? We didn't need the storage.
I think all the T's become C's.
Oh yeah, T's become C's. Yeah. And then we didn't need this. That one we shouldn't need, because that's just saying that exactly what this guy is saying. It's saying it has to be this.
Oh, is that why we don't know?
Okay. Yeah. All right.
Cool. Now we can make our implicit parameters explicit.
Yeah.
It's W and C.
But which one should we put first? Probably you would,
W.
if you ever want to say which. No, I think if you ever want to say which. It doesn't matter with Lean. In Haskell, it would. When you're doing type application, it matters which one you put first because that's easier to use. But here, it doesn't matter.
No,
because you can just say C, and then you can just assign C to something in Lean. That's nice. So
I forget about that. That is good.
If we do it like that.
And I think state global also requires a W on line 44.
Yeah, okay. So let's do it this way.
And then state prime as well.
Oh yeah, I never. Right, this one probably matters because I put them there. So I'm probably. Oh, can I find references?
You're probably using it somewhere.
No, I'm not. Okay. Probably believe that I did need it, or maybe I did need it at some point.
Nice. Cool.
Yeah. Okay. So it does matter if you do. If you do at and then the thing, because you could break stuff if you got the wrong. If you change the order of these, you could actually break stuff.
Yeah.
Yeah, but in this case, not. Okay. We're also missing it from guess.
Yeah.
What we're saying, W E S E. That should be everything.
Yeah.
Only this spelled. If they spelled a word, WCST, can we? Is there an anagram of this which isn't?
Workest?
Workest.
I mean,
we're struggling with vowels a bit.
Yes, that's the
W is almost a vowel.
It is almost coerced. Conserved.
No, and then you're going to tell me there's an Afrikaans word which consists entirely of consonants, which
no, we don't do that. We don't do that. We keep things simple. We don't even use C.
We don't need C.
Yeah, exactly. We don't need C. We have K. Why would you also have C? I don't understand.
Okay.
Can't you see? We don't need C. We only need K.
No, we can.
Okay.
Get global. Get global. Get global. Get global. Brilliance.
Now we can remove global.
Now we can remove global because we should never use that abomination.
Yeah.
This at least checks that you're a global. You're global.
Hmm.
Oh, I've got more get global. Get global. Yes. So now we'll go back to entity. Bye-bye. Hopefully this still works.
Yay. Nope. Let's go fix those.
No. Oh, will this work? No, because I don't have. So now this needs. No, no, I think it does work because. No, it doesn't because it needs. Hold on. Where do we put that? It's in system. Here, what's wrong with you then? Good to know what I'm talking about.
Reload.
Yeah. Component entity. Oh, probably because I make it. I make it a component here. Fail to synthesize component entity counter. Component entity counter. Global storage.
Yeah, that seems to be the 3 parameters.
Yeah, okay, so maybe it's confused by. Let's just fix this error.
Fix both, yeah.
No. Oh, hold on a second. Oh, because it right, okay, so this next entity doesn't require that the entity counter comes from a global storage.
But
so it's saying that, yeah, but I mean, we control this, so it should.
Yeah. So we should.
So similarly for next entity and all these. Oh God, right. But why do these need to be? Right. What I feel like we should be able to say is this next entity
takes an entity.
Oh no, yeah. Well, the thing is, you need all this. No, hold on a second, because because all of these things, all of these constraints are specified here. We shouldn't need to repeat them here.
Yeah.
All right. So why if we just delete all of these?
Make sure that entity counter implements them.
Exactly.
Yeah.
So if we get global, then this only requires it has get, and then we set global, it requires it has set. Okay, so what if we just delete all of this? No.
Yeah, what does it say?
Yeah.
And did you recompile and reload? Like,
yeah, I've done that now. Got a different error. We has W entity counter. That's probably wrong. Oh no, it's not, because we don't. So the has to be here because. Right, because you get we can define the component instance for entity counter here. However, the has instance can only be defined when you're actually creating the world.
Yeah.
So we still need the has thing here. But unfortunately, because so we just need to put the S in, and the S is just global storage entity counter.
Yeah.
Whatever that, and then hopefully you can still figure out what that one is. But we shouldn't need any of those.
Let's see. Hey, nice. Well done. Well done. That's
right. So all of this we don't need, apart from has. And
this one breaks. Yeah, I see. Okay.
Yeah. Wait. So. Oh yeah, we're not okay. So let's see what it's complaining about.
Well, it doesn't.
Oh, because we just need to make this explicit, this S explicit now.
Yeah.
Well, so that's the thing. We're losing some flexibility because we're saying that the entity counter has to be global storage, but
I don't.
It's always good.
Yeah, I think that.
But this is internal. The user will never see this.
Yeah.
You're basically saying that when you construct your world, you have to use this for the entity counter. Now
oh, crazy. Oh no.
Yeah. So I suppose you may decide that you have a global store. No, because I was going to say there are reasons why you want to say, sometimes you want to say, this is one thing discussed in the paper actually, that that entity store is usually a map, but you can get better performance if you know you're only ever going to have 100 entities. You can store them in an array.
Yeah.
And but here the global store doesn't have. There's no array or map anyway, because you just have the global store is just this. You're just storing a counter. So it's actually, there are no entities. So yeah, there would never any reason not to use this.
I mean, technically, entity counter could be a class as well, right?
Yes.
And then it could still be generic. Just be like, this class is an int. Can you do that? Inherit? Yeah, you can do inheritance on, right?
Yes. Yeah, I mean, it's what we do in the store. I think that's what we do in the store. So there's something somewhere that does that. Yeah, right. So we have an explicit init of global storage alpha if we have an inhabited. If A is inhabited.
Yes. You can do something like that. But like entity counter is just a net. I don't know.
Yeah, I mean it's
store that.
Yeah, exactly.
I mean, it could be an int, I guess, but
it could be. You're right.
But like once you figured that out, you just go do it for everyone, because
yeah, there should only be one entity counter, and it should just be created by the. You need some way of you need some way of getting in. You need some way of making these entities, and it has to be actually. You have made a choice because the entity. Oh no, you haven't. I was going to say you have made a choice because the entity is the entity type is encoded in everything, but this is just the entity counter, and you make an entity out of it. But technically, your entity type could have an int in it. If you really wanted, but I think we just say we're not having that flexibility.
Yeah, I feel like you can still get, like, the user doesn't get that flexibility.
Yeah.
But as the framework writer, you can still decide to turn the net into an int.
Yes, you can.
You can decide what's your most efficient way of representing a number. I mean,
yes. So you could have, like, this could be an int, say, and then inside of entity, you could still make it a nat.
Yeah. Yes, exactly. Yeah.
But this is the one. So this is the one that's baked into the rest of it, and this is not made generic. Like, you have not made this depend on something that implements whatever. I don't know what it would be even. Like, it's some tag, right?
There's some number class, and
I hope there isn't. Given what given how that worked out for Haskell, I hope they don't have that.
They do. They have H.
Oh, they have a num class. But they don't put everything in the same class, which is what Haskell does. Yeah. So you could have that, I suppose. Yeah.
Yeah. But like, you're not doing it already, so screw it.
Yeah. All right. So now we just need to figure out which S. We got two. Why have I got two has's here?
I think you just need the line 20 copied, and then couldn't you delete everything?
No, because this one is saying, this saying is next entity, this is saying new entity. So the C has, there are two stores in play here. So we can replace the SE store with the E stands for entity, I think so.
Okay.
But the other ones have to stay because this C is but anything, these ones can go. So I can put this one in and replace this one. And then these guys can go. This one can go. This one can go. This one can go. Yeah. I think that's it. Yeah.
Just get it to compile by deleting code. That's
the same trick here. We replace that one.
Yeah.
And then T he, TC, T he. There we go.
Nice.
And then one more. This one goes, this goes, this goes, this goes. There we go.
Cool.
Yeah, so we do. Oh, hold on. Yeah, because this one says give me the next entity, and then this one says set that component. Yeah, set the entity, associate this set means associate this entity with this component, or the other way around, this component with this entity. Okay. Why did we start doing that? Did we just see it look bonkers? Because we want to get rid of global. Yes.
Yeah.
And then this can now be deriving inhabited. I don't need to worry about that anymore.
Oh.
Yeah, because before you had to start from 1 because 0 was taken. Like that.
Isn't 0 still taken?
No. So because global is special, the global store, if you ask it what If you ask it whether it has a value for the entity, it says yes. And if you ask it to get that value for the entity, it will just give you the global one. So you can. It doesn't matter which number you ask for.
Okay.
For the global one. So we can start from 0 again. Before it mattered because it didn't matter before. It matters originally because I was using the normal store for global storage. And so it mattered that 0 was available and wasn't going to be overwritten by something else.
Yeah, okay, that makes sense.
Yeah.
Actually.
Yeah. Okay. But now we can go back to,
let's see if it works.
System. I can replace global 1 with global.
Yeah, first do that, please. Oh.
Okay, great.
Just like, yeah.
Okay. Great. And if this works,
yay,
it's a good place to stop.
The white screen of life.
Yeah, screen of life. Yeah, I should start with a ball, right? It should start with a ball.
Or
just start empty.
Like click to add, or I don't know.
Yeah. I don't know.
Draw text. That's not in picture yet.
Okay, so we deleted some code. We learned about global and unique storage, and I remember what they were, sort of. Yeah, so global I think is useful. The unique one I'm not convinced by, but
yeah,
because it sounds like if you have like a player and then you accidentally overwrite it, that's probably bad.
And also,
so yeah,
why wouldn't you want 2 players?
Well, if you want 2 players, you can't use unique.
Yeah.
So I'm thinking of actually it would be things like maybe if you had like a menu bar or like some text, like a score thing. I don't know what you call it. Like that maybe that's unique.
Yeah, because I would like to. In Jessica Can't Swim, I want 2 players. Like.
Yeah, so you can't use a unique for that.
Yeah, it would be super easy to add. They're just controlled by different controllers.
Yes. Especially maybe player is a bad example for that. But I think it's
but
the stuff like this score.
People always use because split screen isn't like a popular game option for some reason. It's like one I really care about, but it's not. Yeah. It took me a few years to build up like a library of split screen games to play. Yeah. Now I don't have anyone to play them with me, but I finally have the
No, you do. You have you've got ChatGPT to play.
Oh yeah, my old friend.
ChatGPT solves all your problems. You don't even need to write the game in the first place. And it can also, you don't even need to play the game. You can watch it play the game, and then it can play the game. You don't even need to watch.
I don't know how ChatGPT would do what we just did today. I'm not saying like this was hard, but it was hard for me. But like, that's not why.
Yeah.
How does it know which type classes go where?
Yes.
And it's proven it cannot reason. Well, maybe not proven, but there's been a study to show that it's cannot reason. It's predictive text on steroids. Okay, like that's it.
Yeah,
it's pretty great at that. Like it's pretty amazing at that. Like, but that's what it is. It's just a very, very good version of predictive text. I don't know how it does this. I'm sorry. I don't know how the technology evolves to do this. Like I feel like there needs to be another major leap, not an incremental improvement.
But maybe ChatGPT would say is none of this is needed. It's like, I don't know.
Okay. Yeah, okay,
if you asked it to
fair.
design it from scratch, then maybe it would, its constraints mean that it would come up with something simpler.
Oh yeah,
but then isn't it more likely to come up with something that already exists? I really don't know.
Yes, exactly. Yeah, that too. So I'm not convinced. I think our jobs are safe for a while. But if we want to do this as a job, our jobs is not safe. No, it's paying for this. So we don't need ChatGPT to not have a job. Like we can find other ways.
Yes.
All right, that's a good place to end the stream.
Yes.
And then we'll see you next time.
See you next time.